Thanks for joining me in another video about a radius brake. In the first video, we talked about some of the basics. Like, what is a radius brake? How does it work differently than a regular sheet metal brake? What kind of parts can you make on it? In this video, we want to talk about adjusting the machine and creating usable parts. Now, with a radius brake, one of the first things you need to keep in mind is it's an art form, a whole lot more than a science. With a normal straight brake or box of hand brake, you're getting a very consistent result, and it's kind of a science to it. This is going to require some trial and error and a few sample pieces to figure out exactly how to use the machine. Now, real basic, the top roll is the roll that we're going to use to form the metal around. The bottom roller stays the same no matter which roller we use. Extra rollers are stored on the back side. Depending on the model of machine, you're going to get 5 or 6 different radius tubes that can be swapped out up here on top. They simply swap out by removing one bolt on each side. Take this one off, put the next one on. One trick: if you're going from a small tube to a larger tube, make sure you adjust the machine so there's enough room in between the rolls when you put the larger tube on. Okay, the way we have it sitting here, I'm going to bend a sample piece of 50 thousandths aluminum. Now, the bed of the machine is powder coated black. It gives me a nice contrast to my silver tube. I can sight between my two rollers and make sure that each roller is running parallel to the bed. The material is going to come over top of the bed of the machine, over top of the lower roll. Keeping these parallel to the bed will make sure I get equal pressure on the panel, so that way I have a nice consistent radius all the way across the panel. Now, adjusting the radius brake. We want to adjust the top tube first, get it into its position, and then the bottom tube. So top to bottom, inside bolts adjust the top, outside bolts adjust the bottom. So we're going to move our inside bolts first, get that position, and then we'll move our other roller up from the bottom using the outside bolts. One key thing with a radius brake. What I'm going to do is move my top roller down, and I'll make consistent turns from one side to the other so I don't get the machine into a bind. Right now I have approximately 1/4 inch of gap. Too sloppy for the panel. I want to tighten the material down so I have maybe a 1/16 of an inch of gap in there. About one full turn worked. So I repeat my one full turn on the other side, keeping my tube running parallel. And now I've taken out a lot of that air gap. What that'll do is allow the material to get tightened up. It'll tighten itself against the bed of the machine so it won't slip. Now my bottom roll is down a little bit too far as well. So I'll simply adjust that up. And again, about one turn in this case did it for me. And one turn on the other side. Now my panel can still slide in and out, so I'm not too tight, not pinching it in a way that it might bend the material where I don't want it to bend. But without very much air gap in there, this will tighten up very quickly and make a nice bend. So the machine's ready to go, but one big mystery on a machine like this is, where do I start the bend? So what I've done is I've got a piece of aluminum sample. I've made a 90-degree line to an edge. What I'm going to do is I'm going to use this line as in reference the back side of the machine. In the back of the machine, the bed stops and gives me a nice straight edge that I can line up this mark with. Once I have my mark lined up, I'm going to make a quick sample bend. And now what I've done is I've created a sample piece that'll tell me from the back of the bed, which is a nice, easy to find, easy to use reference point on the machine, how far I need to come from there to where I want my bend to start. So roughly on this particular tube, it looks like 10 or 11 inches, if I string this with a tape measure, will tell me where I can mark my panel to where my bend is going to start. If I do that for every one of my radius tubes, I should be able to easily slide the material in with a mark and know exactly where the bend is going to start on that panel. By knowing that, I can create a part like this. In this case, we were building a cabinet, and the cabinet has a particular dimension that we need to cradle. So this inside dimension is fairly critical. I needed to know where to start that bend on both sides, so I end up with a symmetrical part, two 90-degree bends. You can see some remnants of my marks. Here is where each bend needed to start, and these happen to be the reference points I was using on the back of the machine. So by having these reference points, I was able to make each bend in an equal spot on each edge of the panel, giving me a symmetrical panel. Not only that, but now you can repeat that same panel. You'll notice here I made two skins and duplicate parts. These parts fit together perfectly because I had that one reference point. I knew exactly where I needed to put my material in the machine to make that radius part. Now, a part like this would be very helpful to have something like BendTech sheet metal software. In this case, I had to maintain this dimension. What BendTech software will do for you is tell you where the start of each of these bends is. Draw it up in the software, it'll give you those locations, then you can use your little sample piece to find out exactly where it lined up in the machine. That's a nice way to come up with a very good looking part that's also very accurate. Like I mentioned before, the machine is going to come standard with several different radius rollers. But what you'll find is maybe the part that you want to make or the particular radius that you're after doesn't match one of our roll sizes exactly. Well, there's a little trick to give you some infinite adjustability. By purely dropping your bottom roller down lower during your bending process, you will effectively create a slightly larger radius. What's happening there is you get more spring back in your material, and when that material springs itself back open, the radius gets a little bit larger. That'll allow you essentially to fine-tune to your liking, still using just the standard rollers that came with the machine. Now, counterweight works just like any regular sheet metal brake. It has a little bit of a bend down here on the bottom of the rod. This allows you to position it forward, backwards, wherever you want to give you the most help when bending a panel. You can even remove it for lightweight material where you want to handle all of that by feel right in the handle. Adjust that as needed, adjust your rolls, keep them parallel, and don't forget to make sure you have enough spacing when you swap out those rolls. Now that should get you started in the right direction so you can start producing parts on this radius brake that you couldn't do in any other fashion. Thanks a lot for watching. Check out all the specs on the website or talk to your dealer, but I think you'll find that this radius brake will allow you to make some really neat panels out of steel, stainless, aluminum that you couldn't do any other way. Thanks a lot.